A curve has equation arctan of x squared plus arctan of y squared is equal to pi over 4. A. Find dy over dx in terms of x and y. Okay, so we have this equation here. Arctan of x squared plus arctan of y squared is equal to pi over 4. And we need to find dy over dx. So we could solve for y and then differentiate, but that seems like it would be way harder, and instead we could just do implicit differentiation here. So let's do that. We're gonna do implicit differentiation with respect to x here. So the derivative of arctan is just 1 over 1 plus whatever's inside squared. So in this case it's x squared squared plus, or rather actually we need to do the chain rule here since we have an x squared inside, so we'll multiply that by 2x, and that's that. Since we're differentiating over x, we don't need to worry about dx over whatever, right? So plus arctan again, and so the derivative of that is again 1 plus whatever's inside, in this case y squared. So that'll be 1 over 1 plus y squared squared times the derivative of the inside, 2y. And in this case, since we're differentiating over x, we do need to write dy over dx, right? And that's going to equal the derivative of this. It's just a constant, so the derivative is 0. Okay, we can divide everything by 2 to cancel these 2's here. And we do want to solve for dy over dx, so let's take this one step at a time. We'll say dy over dx times y over 1 plus y to the 4. So that's just this here times the y is equal to, I'm going to move this to the other side, including the x here. Don't forget the x over, and so this will become negative since we're moving it to the other side, 1 plus x to the 4. Okay, and now we can just easily solve for dy over dx. Divide both sides by y and multiply by 1 plus y to the 4. And so we'll have x times 1 plus y to the 4 divided by y times 1 plus x to the 4. Okay, so now we have dy over dx in terms of x and y right here. So that's part A solved. Part B, find the gradient of the curve at the point where x is equal to 1 over root 2 and y is less than 0. Okay, so the gradient of the curve, well, that's just referring to dy over dx. So they want us to find the value of dy over dx when x is equal to 1 over root 2. The only problem is that we have an expression, well, we have an expression for dy over dx. The only problem is that it's in terms of x and y. And so we'll need to calculate the corresponding y value for this x value. And we will, you'll see that when we solve this, we'll get 2 values for y. And we'll need to reject the positive one and take the negative one, since they tell us that y is less than 0. Okay, so let's actually start doing that. So part B, I'm just going to take this equation here, and I'm just going to sub in x is equal to 1 over root 2. So that'll become arctan of 1 over root 2 squared plus arctan of y squared is equal to pi over 4. Okay, and we need to solve for y, so I'm just going to move this to the other side. So I'll be left with arctan of y squared is equal to pi over 4 minus arctan of, and 1 over root 2 squared is just 1 over 2. And now I can take the tan of both sides to cancel this arctan here. So I'm going to go ahead and do that. So I'll have y squared equals to tan of pi over 4 minus the arctan of 1 over 2. Okay, and so now we can actually we can apply the compound angle formula for tan it's in the formula booklet, and I believe it's something like this. We'll get a tan of pi over 4 minus tan of arctan of 1 over 2. So I'll explain what I'm doing here just in a second. So basically, the formula says when we have tan of something minus something, we take this first something and we take the tan of that, and then we do minus tan of the second something. And so that's going here. That's this here, and the first one is this here. So I hope that's clear. It's in the data. It's in the formula booklet. Sorry, this formula is in the formula booklet. What I mean to say. So it's this whole thing over 1 plus tan of. So it's just the same terms again. Pi over 4 multiplied by tan of arctan of 1 over 2. Okay. So now we have that y squared equals, okay, so pi over 4 is a special angle. So we know the tan of that. If you don't remember, I just like to use this triangle to help me remember that. So this is a right angle triangle. These are the side lengths. This is pi over 4. And so tan of pi over 4 is just 1. Okay, so we we know that this is 1. We know that this is 1. We also know that this is a tan of an arctan, so that'll just cancel, and it'll become 1 over 2. Whatever's inside here. Same thing applies here. And so we'll get that 1 minus 1 over 2 over 1 plus 1 over 2 is equal to y squared. We can further simplify this, so y squared is equal to, actually, you know what, I'm going to just do it over here. So that's 1 over 2, that's 3 over 2, these 2's will cancel, and so we'll have 1 over 3. Y squared equals 1 over 3, and so then y is equal to the positive or the negative square root of 1 over 3. And so we can write that as positive plus minus 1 over root 3. And since y must be less than 0, as we've been given in the question, we can say that the y corresponding to this x, in this case, is going to be the negative value. So it's going to be negative 1 over root 3. And we can reject the positive there. Okay, so now we found the corresponding y value for this x that we've been given. Now we just need to evaluate dy over dx with these two values that we have. So I'm just going to take dy over dx, the expression we found in part A. dy over dx, okay. And I'm just gonna indicate that we're evaluating that for x equals 1 over root 2. So now we can just substitute in the values. 1 over root 2 for x. 1 plus y is negative 1 over root of 3. The whole thing is to the power of 4. Divided by y, 1 over root 3, negative 1 over root 3, sorry. Multiplied by 1 plus 1 over root 2 to the power of 4. Okay? And so now, okay, so we can start simplifying a bit. So we have 1 over root 2. Well, first we have this negative here and this negative here. And so those two will just cancel, and that'll become a positive. Then we have 1 over root 2 over 1 over root 2. So in other words, we just have root 3 over root 2. And then we have 1 plus negative 1 over root 3 all to the power of 4. Okay, so the negative will just disappear since this is an even power, so that'll just become a positive. And it's 1 over root 3 to the power of 4. Okay, so that's 1 over 3, and then square that, so 1 over 9. 1 over 9, and it should actually be 1 plus 1 over 9. Can't forget the 1 plus. Over the 1 plus 1 over root 2 to the 4. That should be 1 over 2, and then 1 over 4. So I'm just squaring it twice. And so now we have this expression. We can simplify it. So root 3 over root 2 times 1 plus 1 over 9 is, well, that's 9 over 9, so that's 10 over 9. And that's over 5 over 4, I believe. And so that'll become, we can divide everything by a 5. That'll become a 2, that'll become a 1. And so it's 2 over 9 multiplied by 4. 2 over 9 multiplied by 4. Okay, so you have a root 3 over root 2 times 4 times 2 over 9. Okay, and so 4 times 2 is just 12. Okay, so we have 12 over 9. Or sorry, it's not 12, it's 8. What am I saying? 8 over 9 times, well, 8 over 8 root 3 over 9 root 2, I should say it like that. And that is, we could leave that as a final answer, but I'm gonna clean it up a little bit. So I'll get rid of the square root in the bottom by multiplying both the numerator and the denominator by root 2. And so the denominator will just be 9 times root 2 times root 2 should become 9 times 2, which is 18. 8 times root 3 times root 2, so the roots will combine into 1, so it'll be 3 times 2, so it'll be root of 3 times 2, which is 6, and this will be an 8, and I can divide by a 2, so I have 4 times root 6 over 9, and that should be your final answer there for part B.